put these back into this experiment. Two, which is 9. I don't know. I mean, I didn't do it that way. I don't know.
Alright, so the whole game with these is to take one side with an amorphous blob of a lot of logs and crush them together. I'm using the product property where if you have 2 logs added, then we can put them together and multiply the inside. We get 9, and this side is happily just x, so if log 3 of 9 equals log 3 of x, then we can equate the 9 and the x. Voila. Right? That's the game with all of them for the most part. This would be the same thing. This side is happy by itself. They're all base 5, which is nice. So I'm going to try to crush this side together, keeping base 5. Now, this is being subtracted, so I'm going to be able to divide the inside bits. Doesn't end up looking real nice. But it doesn't really matter, I think, in the end, because if log base 5 of all of this equals log base 5 of x, then we can say, therefore, x must equal this ugly mess. What is this going to turn into? Jerks! But it's not you guys, the makers of the makers of this question, right? So it's a log question with quadratics built in, and you can kind of see that coming because 2 x's show up. We start multiplying them. Like that. You get 6x minus x squared equals 8. We kick everything to the right-hand side. So you get x squared minus 6x plus 8. And then you can factor it, or this one's factorable, but blast it with the quadratic formula, or whatever you like. So what, 4 and 2, and negatives. So therefore you get x is 2 and x is 4. Are both of those solutions valid? Or could they be? Are you skeptical of either of them?
No, they're not.
Yeah, I think they're probably good. The 2 things that I'm looking at are this. Denominator, screaming, flashing lights. Like, that thing can't be a 6. You get 0 in the denominator and the world blows up. So, I'm good. Neither of these are 6. What's the other flashing thing that's going to wreck our day mathematically? Yeah, right. If one of these is like -2 here, just making stuff up, if this came up as -2, and we tried to put a -2 back in there, this is like, I got a log base 5 and -2. This is like, I got a bunch of 5s. How many positive 5s multiplied together give you -2? It doesn't work that way, right? You can't multiply positive things and get a negative. So a negative might send a little flashing alarm at you. It doesn't mean it's completely never going to work, because once in a while you get like x plus, I don't know, 7 in there. And then the -2 is cool, because -2 plus 7 is 5, and so this will be 1. So just because you get a negative result doesn't mean it's bad. Just check it. Make sure it's all right. Right? And the 3 things to look for are negatives in here, 0 in the denominator, or maybe if there's a radical, make sure that the negatives up there are radical. Cool. There's one trick. Ka-bing! Uh-oh. Your calculator died. You can still do a lot of these without that, right? Without your calculator, even if they look gnarly, right? Like, they say log base m, t of m, I've got a bunch of t's multiplied together, and I'm trying to get this. I have m of them. And they tell some other pieces, right? They're really trying to get you to see if you can break things apart and see them, with through the lens of the log laws. So I'll do this one with you. They're asking for what's log base t of n. Like, well, that's not going to help. But maybe this one. Log base t of this is log base t of n squared. Right? Is 1.72. what we can do is modify this. I know log t of n squared is 1.72. I'm looking just for n, not n squared. So let's rip this 2 out, kicking and screaming into the front. So this becomes 2 times log t of n. There's 1.7. Oh, I'm looking for this piece to divide by 2. Right? Divide both sides by 2. You're just left with log t of n equals t. Oh, there it is. Cool. Divide by 2, you get 0.8 something. Try that same game with this, and you're going to be combining this and this or this in here somehow. Try that out.
So we wouldn't have our calculator for questions like that?
Right.
So we would have to know what 1.72 divided by 2 is.
You can do really hard things with logs. Yes.
Okay.
Yes. Yeah. But they will ask you to divide by some number like 2 and not like 14. Right. They want to see you flex your logarithmic muscle and not be just like a calculator, right? I don't want you to be a number monkey. I want you to be able to think about what you're doing. Okay, so log base t of m times n really is log base t of m plus log t of n. They told us log t of m is 129. Bring it back, T. Bring it back, T. Goes. Thanks. And we figured out this one already. It's 0.86. And so now is the time to get out your calculator and throw decimals in. Kidding. You end up with 2.15, right? We're just adding those up. They will do this same thing, maybe without gross decimals. Maybe they'll tell you it's like A and B. And so this thing would be, they'd say, this is actually A. And so when you divide by 2, you get half A. Right? And I actually prefer that because then I don't have to divide gross decimals. And same thing here. Maybe you'd end up with A and B, or B and A. And you leave it as B and A. Right? They like that a lot because you're leaving it in terms of those pieces that you don't actually have to combine. All right, last trick. On your calculator, you also see ln. You'll hear people say ln. I try to say like natural log because e is the natural base, and it reminds me that it's base e. And so when I'm working with natural log, I stop writing ln, and I just write base e because it helps me remember all of the tricks if I can see that base. So for something like this, people would say like ln of 27. I don't. I try to say natural log or log base e because it helps me remember, and I need all the help I can get. So we can do all of the same tricks with this, like show that natural log of 27 is this. Well, you can say, well, log base e of 27. 27 is 3 cubed. And so therefore you can pull the 3 out and go 3 log base e of 3. Right? And turn it back into natural log if you really like. What's that? The difference between natural log of writing it like natural log of A or log base E of A. The difference is this one I can see the base, and so it's easier for me to like move it around, switch it into exponential form. I think it's more efficient because I don't have to think about it as much. Where this one's a little faster to write, but I think that's negligible.
If you're giving answers and they give you ln in the
They'll take either one. You can leave it as this, completely acceptable, or 3 natural log 3 is acceptable. I mean, this looks smoother, and if you're using this a lot, if you're using the natural log a lot and moving it around, just like writing it as ln. If I'm switching back and forth and using the base, say change the base rule, I use the base on it. But that's like your mathematical art form. You try that same thing with this one. Show that that is really bad. So take the left-hand side and see if you can change it, and eventually turn it into that.
Oh shit, that body
So there's a natural log because they use the natural base E. I don't know if you've ever seen these, but they make like it's like sawdust and compressed sawdust and wax, and like you light them on fire in your fireplace and they burn really nicely. And they're called Duraflame. So that's like the unnatural log because it's not a real log; it's compressed stuff. Whack. So trying to show that this is this. This is the beginning of proof, and we'll do little bits of proof along the way. They ask for these show that's, and usually I'll take one side, completely ignore the other side, and just change this little bit by little bit. We'll do this a lot in trigonometry. It's kind of interesting. So I might write like natural log base E. I'm going to change the 3 to a half, and just kind of be careful with the parentheses. Use the power rule to do that. Log base E, 3. Yeah, and then just leave it as half natural log 3, which is what we were looking for. Yeah. Right. Now, like that's probably they would give you probably a point for that, like a show that, and therefore you show as many steps. If you know if they're going to give you only a point for that, show as many steps as you can, because they're looking for one specific trick, and probably it's this trick where you're pulling out the half. Like that's the log trick behind all this. Cool. Questions, comments, concerns? There's a log equations in your packet. Aim for that. Spiral review. Also, if you would like a new one, you can just work on that one, or tomorrow I'll switch you out. And remember that Valentine's Day is coming, and so you should make sure that practice doesn't get in the way of your love life at that point.